All right, I think we are live. I got the chat up. I already have a bunch of people asking for things to do. Let me do this. Okay, so welcome to exam review. Okay. So, this is Algebra 2 exam review. Any of my Algebra 1 students tuning in, you're out of luck. Stuff we've been talking about forever and ever. It is 40 multiple choice. That's worth 80 points. You have 4 short answer problems. That's worth 20 points. So let me elaborate on these actually. You have your honors and on level. So 4 of them, or 3 of them are pretty similar. You're going to have compound interest, you're going to have graphing hyperbolas, graph hyperbola. You're going to have, what's the other one? You have, rational equations. So those are all what they share. The differences are going to come in the one of the problems. For honors, you're going to have to create a polynomial using certain roots, and we'll go over that tonight. And then for on level, you'll have to do the grid of zeros, which I don't remember what a better way to call that is, but that's the one where you have what are the positive, negative, imaginary, and total zeros in a thing. So on level, this is what your 4th problem is going to be. Honors, this is yours. I'm going to go over most of these because that's 20 points, and a lot of these ideas are going to come in to the 40 multiple choice. So I already got a couple of requests. What I want to do is graph hyperbola because it's going to be on both, and it's the only graphing. This is the only graphing you're going to have. Couple housekeeping things. If you need to, you can always rewind this live stream and go back and see some of the things. I'm going to do my best to, I have a little graphic I made, so if I'm doing a problem that only relates to honors, you should see this. And so that's my little, so if you're on level and you see this, you can effectively ignore it. But if you're honors, you should pay attention. So if I do a problem that involves honors only, I'll be sure to denote that. All right, so let's start with graphing hyperbolas. Let's see what some of the chat is saying. Yes, can you just write it? Yeah, that's what I just said. How do you find it? Okay, so let me start with one of the short answers. This is for both people. We'll call it number 1. It's not really, I don't think it's the first one on either, but we'll start with number 1. So we're graphing hyperbolas. If I'm going too fast, number 1, that's probably normal for you all. And number 2, you can always rewind this, pause it, go back. This will be up afterwards in case you would like to see it again. Graphing hyperbolas. So we have something like y equals 1 over x plus 4 minus 3. So I want a couple things. I'm going to graph it. I'm going to talk about where it's undefined. And then see over here, I guess. We want the asymptotes. Now this problem that you're going to see is exactly the same as your quiz and test. This is chapter 8. I don't remember when. Test and quiz. So this problem is going to be exactly the same. Defined the exact same way. We'll start off by graphing. So we have a hyperbola. We know that by having the x in the denominator. So having the x in the denominator means that I know the shape of it, and I know these things are going to play into it. This means I'm going to go left 4. This means I'm going to go down 3. Now what these are going to do, these are for our asymptotes. These are for our imaginary lines that can't cross. So down here at the graph, I'm going to go down 3, 1, 2, 1, 2, 3, and then left 4, 1, 2, 3, 4. You'll be given a graph as always. So that point right there, make it a little bigger. That point is left 3, down 3, left 4. And I'm going to extend these to go all the way up. These are going to be our asymptotes, our imaginary lines, our graph can't cross. We talked about kind of the shape of it, and I really sort of skipped over how to make it perfect. We only are going to have them in the top left and bottom, top right and bottom left quadrants. And the graph is just going to kind of be up here. It's not going to cross either of these lines, but it's going to kind of come close and go like this, and over here, go like that. Little reminder, no right angles. It's not going to go like this and this. Don't do that. So that's our rough graph, and we got that by looking at how it moves, drawing these asymptotes with our new center. That center came from these guys, and I made my little swoops. So that's part 1. We're going to graph it. Part 2, where is it undefined? Well, it's undefined wherever whatever we plug in for x would be equal to 0. So we're looking at the opposite of this. So it's undefined at x equals -4. Because if I put a -4 in here, -4 plus 4 gets me 0. So there's my answer for that one. And my asymptotes. My asymptotes are the vertical and the horizontal over here. The one going up is x equals -4, and that's the same thing as our undefined. These are going to always be the same one. Y over here, we're looking at where it crosses the y-axis, and that's at -3. So these are the 3 pieces you need to know. This is your short answer, basically. I change only really these numbers. What is the hyperbolic equation given is negative? So it shouldn't be negative. It should still be top right, bottom left, because what we're focusing on here is the translation of the graph, not the turning it side to side and flipping it. All we're talking about is moving it up, down, left, and right. Let me put him in. Okay. All right, so that's graphing hyperbola. That's one of your short answers. Let's jump to another short answer. All right, so I'm going to put on the honors question 1. We're going to make, one second, I think we have one more question. Do we have to draw the dotted line? You don't have to, but it'd be good if you did. Okay, so here's your honors question. We want to create a polynomial. With roots. How about -3, 2, and -5? I have good news for you. If you showed up here, I will let you know a little secret. This problem will not have imaginary numbers. So there you go. this problem will not have imaginary numbers. That just takes too long. Easy things to mess up. So we're just going to do it with real numbers. And so a thing we need to remember is x minus the root. That's our thing to remember. So if we know x minus the root, what we're going to do is set up this equation as this. X minus negative 3 becomes plus 3. X minus 2 and x plus 5. So to create a polynomial with these roots, we had to do x minus the root, and now we're just going to multiply all these together. So first I'll do these two. That'll be x squared plus x minus 6, x plus 5. So then I have this. I'm going to multiply these two together, and what I'm going to do is distribute here x plus 5. Once again, the little border around the screen means this question will only show up on the honors exam. I'll do the on-level equivalent next. So I have x cubed plus 5x squared plus x squared plus 5x minus 6x minus 30. Okay. X cubed plus 6x squared minus x minus 30. All right, and there's my answer. This answer is important. Here's another little tip for the exam, not related to this question, so let me turn off the honors thing. So not related to this question was make a polynomial with these roots. We did that. If I were just to give you this question, I'll let you know this is one of the questions on there. If I were to give you this and say, how many zeros are there? This question is meant, it's the same question as, what is the degree? Because the degree and how many zeros are going to be the same thing. The degree and how many zeros are going to be the same thing. So there are 3 zeros because that's our largest exponent. So one of the questions I'm going to ask in the multiple choice is, how many zeros does this polynomial have? We're looking for the largest exponent. So this is creating a polynomial given certain roots. We do x minus root, do that 3 times for each one, multiply them all together. It does not matter what order you do it, but you should be able to get the same answer either way. You can plug it in your calculator and double check it crosses here, here, and here. So for example, it will look like this. 1, 2, 3, 4, 5. And 1, 2, it should hit here. It should hit here and here, so maybe something like this. Oop, missed it. Something like that. So, create a polynomial with these given roots. That is honors, short answer. If you need to go back, you can rewind this. This will be available afterwards. How do we find the sum of interior angles? I'll leave that to you to figure out. Spencer. Okay. I had a request to do one from this section. So let me put a little star by this one. This one is a very good example, if you understand what I'm saying. So, this one, I'm going to do these problems as if they're not going to be multiple choice, because that's easier for you if you know how to do these and you're just pleasantly surprised that there's options. So pretending this is not a multiple choice, then we'll solve this. So we already start off with nothing besides the square root and then this 3. So my first step is going to be to square both sides. If I square both sides, I get rid of the square root. 2x plus 3 equals 9. And then from here I can solve like normal. Minus 3, minus 3. X equals 3. So once we get here, if you're not sure that if this is going to be the right answer, all you have to do is plug it back in here. And we can see, okay, 3 times 2 plus 3. That's 6, 9, square root of 9 equals 3. We're good. So you could, if you had this problem and 4 options, you might be able to figure out that it's 3 without doing all of this. But if you know how to do this, it's only helpful. So this is probably this will be something on there dealing with radical signs. All right, let me jump to the chat and see what everyone's talking about. Linger asking to go over 5-4. Wait, Spencer, you're in Algebra 2. Spencer is not in Algebra 2. Please stand by 1 second. Okay. Let me go over another one. This is another good problem. Square root of 5 minus 2 square root 2, 3 square root 5 plus 4 square root 2. One second, let me answer this. So this is a good problem. Hint, hint. So make sure you know how to do something like this. It shouldn't be too difficult. You see 1 parenthesis, so this should mean FOIL in every time you've seen something like this. So when we FOIL these together, we're going to multiply the insides times the insides, the outsides times the outsides. So this becomes 18 square root 25 plus 24 square root 10 minus 6 square root 10, and then finally minus 8 square root 4. A couple things to note. You have things that can simplify. You have 4s and 25s. So I'll turn to 18 times 5, 4 root 10. Uh, 18 times 5 is 90. 50 times 40. 90 plus 24 and 6. I'm going to subtract 6 from 24 because they have the exact same thing under the radical. That means they're going to work similar to variables. So this is now going to drop down to 18. Yeah, 18. 18 root 10 minus 16. I have 90 minus 16. That's going to be 74 plus 18 root 10. These cannot combine. There's nothing inside 10. There's no squares inside 10 that I can take out. So I'm stuck at 74 plus 18 times 10. Once again, this is a star problem. I would know how to do this one for everybody included. So let me jump down to chat. Oh, let me just put him in timeout. 0 is the same as asking how many zeros. Is finding all the zeros the same as asking how many zeros in the polynomial? No, that's a good question, Chase. Let's jump to one of those problems. All right, it's going away. If you need it, reverse time. So I'm going to do kind of something in the middle of these questions you've asked. Let me turn this on because we're going to have just honors for this one. I believe Brock asked for this kind of question as well. So this is on the test, given x minus 2 is a factor of x cubed plus 6x squared minus x minus 30. Find the others. All right. I believe Brock asked a question about this, and this is sort of like Chase's, where we're given this factor and we have these. Saying that that's a factor is the same thing as saying 2 is a 0. So if we don't have this first part, and it's saying find all the zeros of this, we could just take our calculator, plug it in. We say something like x cubed plus 6x squared minus x minus 30. And we'd see, great, 2 is a factor. Actually, this problem is going to work really well with one we just did. This is not on purpose, but as you can see, former Mr. Goodrow and current Mr. Goodrow are thinking very much alike. So to find the rest of these, knowing that x minus 2 is a factor, we're just going to divide this whole thing by x minus 2. I'm going to do synthetic division, just because I think it's easier. So synthetic division, I put this 2 in here. It's the opposite of this. And then we'll put every coefficient out front. 1, 6, minus 1, and minus 30. So once again, this is the opposite of this number, and I put every coefficient out front. So I will drop this one down, multiply here, 2, add these, 8, 16, 15, 30. So I end up with x squared plus 8x plus 15. All right, now that I've got that, I can factor this like normal and think what adds to 8 multiplies to 15. That'll be x plus 3, x plus 5. So these are the remaining factors of this. So we took that, divided it out. So if we're not given this leading thing, if we just say find all these factors, we would probably use our calculator, plug it in, and see if we can find one, and then do this. The next thing I want to do is compound interest. We'll do an everything compound interest. So let's write everything I know about compound interest on a couple sheets of paper. So this is a star for on level and honors. This is one of your short answer. This will be on like 1 or 2 multiple choice too. So just knowing compound interest is going to be really important. Just knowing compound interest is going to be important. We have 2 equations. We have A equals P, 1 plus R over N to the NT, and A equals P to the ERT. Hopefully that's clear that the R and the T are in the exponent and the P and the E are down here. This one is discrete. This one is continuous. It means this one is growing at certain times, while this one is always, always, always growing. This one is always growing. This one is growing at certain times. This one's going to use words to describe its growth, like monthly, quarterly, daily. This one is only going to use one word. That's it. The only way you can get this equation is if you see in the problem continuously. And when I want you to use this equation, it'll say that. On level, you'll be given both of these in the very front of your exam, but you'll have to know when to use it. Monthly, quarterly, daily. So let's say, let's find a problem, some numbers that we can use for both. So let's say I start off with $10,000. I have 5.6% on either. Let's say I have 10 years. And let's say it grows monthly over here, and then continuously over here. They're going to be set up pretty similar. My P is always this. This is my rate. This is my time. Since it's monthly, we have 12 months. It's going to grow 12 times a year. And this one, all I need is P, R, and T. P, R, and T. So to set this one up, A equals 10,000. Uh-oh, we're going to run out of room. 10,000. 1 plus. My rate is going to be 0.056 because it's in decimal. Then my N is 12. 12 times 10 exponent. Over here, 10,000 E 0.56 times 10. So those are my two setups. Let me plug those in the calculator. Let me plug this one in and see what I get. E to the 0.056 times 10. All right, and I get 17,506.73. Put a dollar sign in there. That is my continuous growth. My other one, I actually made a program for it. $10,000 at a rate of 5.6. 12 times a year for 10 years. I get 17,483.94. Kind of similar. But that is all of my compound interest. What you need to know, if you're in honors, you know both of these equations. There's no really easy way to memorize them, but if you get them, you get them. Everybody needs to know these words. Stuff like continuously is going to point to here. Any one of these is going to do this one. How to plug this stuff in. Remember, R is divided by 100. This is the stuff you need to know for compound interest. All right, let me check the chat. What about the A equals K equals no K? If you have a program that does funny stuff, if it didn't come out with those numbers, double check it. Make sure your program has enough parentheses. Parentheses are normally what get people. Kind of like this, let me jump into a exponential growth and decay problem. So this is definitely honors. We have, Mario, your question, what is quarterly? Quarterly means it grows 4 times a year. 4 times a year. So this is honors. We have y equals A, E, KT, and y equals A, E. I'll put a -1 KT because K is always positive. K is always positive. If it's decay, we add that -1. So let's say we have a city we're growing. Let's say it doubles every 12 years. Doubles every 12 years. Find k. If I want you to do this on the exam, it'll probably just be finding k and not using it. So we're just finding k. We have something that's growing, it's doubling every 12 years. And that's actually everything we need to know. We have 1, 2, 3, 4 variables and 2 givens. So it doesn't seem like enough to find it, but what we're going to do is change a and y to be one variable. So instead of this is decay, we'll use the growth one. So for example, y equals a e k t. Instead of y and a, I'm going to write them as, let me use this as a big arrow. 2a equals a e k t. Now what I did here was instead of saying y, my final number, I know my final number deals with my starting number. I know it's going to double every 12 years. So whatever my a is, let's say a is 100 people in this town, in this city, it's going to double to 200. So I can represent y as some relation to a. This is always your step one. Step one is to find y in relation to a and then substitute that in. Because now I have 3 variables and 2 givens. Since 2a and a, I can just divide both sides by a, and my new equation becomes 2 equals e k t. So before I've even put in my years, I've gotten rid of y and a. I've gotten rid of y and a. That's pretty much step one. So step 2, I'm going to change out my t, my time, for 12, because that's the time I've been given. It's the only thing I haven't used yet in the words. So I have 2 equals e k 12. And now we have a problem, a classic logarithmic problem. So if you're on level, this would be a good time to pay attention. How do I solve this? What we're going to do is I'm going to rewrite this as log e. E to what power is 2? Well, that power is 12k. But remember, we don't write log e. So I'm going to write it as ln 2 equals 12k. So what I did here is I had 2 equals e to the 12k. I'm going to take this exponential form, put it in logarithmic form. This is not proper. We don't have log with a little e. We write it as ln, the natural log. So these are really the same thing. This is just more of a format. And then finally, to solve for k, move the 12, move the 12. K is going to equal the natural log of 2 over 12, which is about equal to, let me get my calculator out. Please, please, please remember to charge your calculator, bring extra batteries. I will not have one to give anybody tomorrow, so do not come asking me. Do not come asking for a calculator. I plug that in, and I get about 0.0577. So that's my k. It doesn't really mean anything. It doesn't relate to a real world phenomena. It's not saying 5% of people do something. It's just saying a number we'll use to represent doubling every 12 years. So that is what you need to know for continuous growth honors kids, is finding k from this. And this is really probably too much work. You could do this about half these steps. So solving for k is the big one, if I'm going to ask you to do that. It's a little tough. It's probably one of the tougher things I could ask you, but it's good practice. So yeah, remember, this is honors. All right. If I miss your question, put it back in the chat. I will go back through it. Unless it's a dumb question that has nothing to do with this, then I will kick you out. We're going to short answer question for exponential growth and decay. You could, Happy. You could also look back at the first thing we talked about, and that lists all the different kinds of questions you'll have. So let me look at what we have done, what short answer I have not done. Oh. I'm also going to look on the exam for things that will be hard to do, that we have not talked about. Let's do... Oh, I want to do a conic section for some of the honors stuff. So let me put the honors banner back up. All right, conic sections. I'm going to do a quick ellipse problem. Something like, how about here and here? Let's say it's -3, +3. Let's say it's 5 and -5. And so we have some kind of ellipse that goes like this. But it's foci up here. All right, once again, this is honors. Find the equation for this ellipse. Find the equation for this ellipse. I think this will work. I have not checked. So what we're going to do is once we run into this problem on our exam, we need to go look at the front of our exam, and we'll find one of our note sheets. I don't know where mine is. Oh, here it is. All right, we go to the front exam and find our things, and we remember, oh, well, we have this equation, y squared over a squared minus x squared over b squared equals 1. This is for vertical, and I know it's vertical because my foci are lined up. I know it's vertical because my foci line up vertically. So I only need to find a couple things. I only need to find a squared and b squared. If I find those, I'm happy. So what do I have? I have two distances here. I have my longest axis, which hits from here to here. It's this far, and my shorter axis, which goes from here to here. So this axis is 5 to -5. So that's going to be 10 units long. You could remember your distance formula from a long time ago, but you can also just count. You can say, well, there's 5 this way, 5 this way. Similarly, this one is 6 units long. So I have my longer axis is going to be 2a. So my long axis is 2a. Also known as 10 equals 2a. So a equals 5, and then my short is 2b. So b equals 3. The important thing here to remember is that I want a squared and b squared. The equation has a squared and b squared. I don't want a and b. That's going to be how I'm going to trick you on the exam. I'm going to leave these as 5 and 3. You need to turn this to 25 and 9. So the equation for this parabola is y squared over 25 minus x squared over 9 equals 1. For honors, the conic sections is not meant to be hard. It's meant to just be a little primer before you get to Ms. Johnson's class. So we found this formula first. We went on our sheet in the front. We said, oh, there it is. And then we wrote it down and then solved for these. Once again, this is chapter 9 stuff. That'll be a couple multiple choice honors. Okay, let's see what the chat's saying. So let me go back. We have some things about K. Can you do logs real quick? Yeah, sure. And then I'll do some factoring, like Addie is asking, and 5/8 is kind of like factoring. And I think I know what Brock's saying too. Imaginary numbers, there's not really a lot of imaginary numbers. Okay, logs. For example, if I have 4 squared, oh, that's a bad example. How about 5 squared? 5 squared equals 25. What I'm going to do is take this information and rearrange it down here. That's what logs are. They're taking our information that we have and writing it a little differently. So the first thing I'm going to do, I'll take this blue one, and that's going to be our 5 is going to come down here as the small number. So we become log with a little 5. That lets me know that's my base. That's my this to this. And it's going to be 5 to what power gets me 25? 5 to what power gives me 25? Well, the answer to that, the power that takes 5 and gets me 25 is 2. So I have log 5 of 25 equals 2. It's a question of what is my exponent if I had this and I got to this. What exponent gets me from 5 to 25? Well, that exponent is 2. Conversely, you can go the other way around. Know how to do this. This will be on a couple problems just because we use this all the time when we're solving logs. So know how to do this. Some problems, this is the only way to solve it. So if I had log 2 of x equals 4, that x is kind of trapped in the middle until I can move it around and say 2 to the 4th equals x. And then 2 to the 4th is 16. So we had to know how to take this and go to this. So whatever you need to do to remember this, go for it. Everybody's going to need to know a couple of these. You need sum of 2 cubes. A cubed plus b cubed is going to be a plus b, a squared minus ab plus b squared. The way we remembered this is for this and difference of 2 cubes, which would be cubed. I'm going to leave the signs out of it for a moment. If you see here, these are going to be the exact same every time. You're going to have the first thing, the second thing, a squared, ab, b squared. All that's going to change are the signs in here. Our little acronym for this is SOP. We have the same sign here as we have over here, the opposite sign, and then finally this is always positive. So to help us remember, this is going to be the same sign, this is going to be opposite, and this is always positive. So if you ever forget which sign goes where, you need to remember SOP. You need to know these. These will probably just be a multiple choice for everyone. Just what is the sum of 2 cubes? I'll give you a bunch of equations, and you have to pick this one. So know this, know how to derive it. If you're in honors, know how to find it in on level. This will be on your note sheet for on level. On level, this is on your note sheet. Everyone else, you will have to draw. Honors, you'll have to know this by heart. But if you remember same, opposite, then positive, hopefully you can do this. If you have no idea, you could always multiply these together and get back to here. That's probably a lot harder. But sum and difference of cubes, you can know that one. Also, difference of squares. Difference of squares shows up actually in a couple sections, which is a squared minus b squared. And that's a minus b, a plus b. Doesn't matter what order you do it in. I normally do it in minus then plus, but you can do it anyway. These are all going to come back. These are all going to be in chapter 5. So look out for these. You'll use this, but these will probably be questions and multiple choice. What equations should you memorize? That's Diane's question. That's a good question. So let me jump to honors real quick. Honors, what you need to memorize are these. Compound interest. There's 2 of them. What else do you need to memorize? Kind of this. That's kind of memorizing it. It's not, I don't know. You need to memorize. Make sure you know these for sure. It always helps to have the quadratic formula. I don't think I did any of those on here, but it can't hurt you. Quadratic formula. But these 4, or 1, 2, 3, 4, 5, 2 compound interests, those are the main ones. These you can probably do without. Let me look at your exam real quick and figure out which ones you definitely need to know. Yeah. Honors, you also need to remember y equals kx, y equals kxz, and y equals k over x. I'm not going to have you do problems with these. You just need to remember the different names. For example, this is direct variation. This is joint variation. And this is inverse. So you just need to know the equations and the names. You don't know how to use them. You just need to know what these are. So honors, hint, hint, know that. What else? Conic sections, you'll be given those formula. So you'll be fine there. All right, let me go back to everybody else. Okay. What else do we need? Someone has to go over fog and Goff. Yeah, let's do that. Fog and Goff. If I don't get to your question, please put it back in the chat so I can see it. I'm not purposely ignoring anybody. I promise. All right, so I have your exam right here. That's it. Let me do this one. So on level, here you go. Do this. Hopefully you enjoy this problem. P of negative 2 for P of x equals 3 x squared minus x. On level, people, you should remember that this problem should be familiar because this shows back up this is in your book, like this carbon copy of this problem. So what this means is take negative 2, put it in for there. So 3, negative 2 squared minus negative 2. 3 times 4 plus 2, that is 12 plus 2, 14. Fog and Goff, this is going to show up. I don't know if I put Fog and Goff actually on here by the end of it all. Yeah, Fog and Goff didn't make it, but this idea did, and it's a little similar. for honors, if I put a equation here, that's going to function like Goff. What is 5/8? I have no recollection of that. 5/8. Someone tell me what kind of questions are 5/8, and I'll do those. Jen asks, have we done conic hyperbola problems? And Mad Dog says hi. Tell Mad Dog I say hello. Conic hyperbola, I don't think so. Those are a little harder. Let's just say no hyperbola. Let's just say no hyperbola. But we can do a circle. Let's do a circle one. All right, back to this. So we have a circle. Let's say it exists over here. What do I have right there? I'm going to say the center is, how about -5, 3? And then this point, let's say, is -8, 3. How it ended up happening on your exam honors is these didn't show up too well, so I had to put these as well. So this is how you're going to see it. Tati, to answer your question, Fogg and Goff kind of did, because if I do this, and I say P of x minus h, that's going to function like Fogg and Goff. We have 3 x minus h squared minus x minus h. And you do all that. So yes and no. Fogg and Goff directly aren't, but taking equations and putting them in equations is still going to be on there. All right, to do this problem, I need to remember my circle equation. So I go to my handy dandy sheet. I say, oh, there it is. I want x minus h squared plus y minus k squared equals r squared. A couple important things. I'll show you the most common ways to trip up. So I really only need h and k and r. H, k, and r squared. I don't care really what r is. I really just need r squared because that's in my equation. Luckily, h and k are our center points. H and k. So h is -5, k is 3. Easy enough. I have a couple of options to find r. I could take my graph and look at this and count that distance, or I could plug in both of my points into this, which is how I'm going to do it. I think that's the more rigorous way, probably the easier way to sort of make sure you get the question right. And so I'm going to take h and k, plug them in there, and this will be my x and y. So my x is going to be -8, I don't know, a comma, minus -5 squared plus 3 minus 3 squared equals r squared. -8 minus -5 is going to be -3. And I get 9 equals r squared. So I don't really care that r is 3. I just care that r squared is 9, because now I have every piece I need to make my equation. I'm going to do x plus 5, x minus 3, oh no, plus in the middle, there's a plus in the middle there. And there's squares over here, equals 9. That's not really pretty, but hopefully you get what I'm saying. All right, honors, that's your conic section circle. Can we go over rational equations, please? Yes. 5/8 had imaginary numbers. 5/8 had imaginary numbers. I can't for the life of me know what that means. Let me think. I did not bring my book home, so let me look on some of our old tests. Look at the on level. There are very few, if any, imaginary numbers on this exam. Very few imaginary numbers on this exam. Just because that wasn't really one of our sections. That was last semester, so I wanted to make sure you understood it then. But this time, it will not feature very prevalent. Let's go over rational equations. Those are fun. I mean, you guys don't like them, but I like them. So, let's do a very good rational equation, if you understand what I'm saying. Let's do a very good rational equation. Plus I have this. You can put this over 1. Really doesn't matter. If that helps you see everything, go for that. So honors people, make sure you're following along. Not honors, on-level people, make sure you're following along with this problem. So what I need to do is find my LCD, my least common denominator, the thing that all of these have in common. Well, I need a 1, but 1's in everything, so I don't need to worry about that one. I need a 3. I need an x minus 2. So this is going to be my little secret, and what I'm going to do is multiply this by every single piece. If I multiply this by every single piece, I'm going to have something cancel out. On level, remember this. Right, now that I've done this, I can see I have everything lined up, and what I want is to cancel every one of these denominators. Well, this is a 1, so it doesn't even exist. I added it up here, but if you don't want to have that here, you're fine. So here I have an x minus 2 and an x minus 2. Those are going to cancel with each other. Over here, I have a 3 and a 3, and those will cancel as well. So what I have left, I have this 1, which isn't going to change it, but I'll have x minus 2, keep that there, 3 times 4, so it's plus 12, and then I have this. I've seen a lot of people get tripped up on this. What I'm going to do is I'm going to combine these first into 18 and leave x minus 2 there for a little bit. All right, well, I have x minus 2 plus 12 equals, and I'll distribute this in 18x minus 36. It's a negative 36. The biggest problem is people forgetting negative signs. So x plus 10, negative 2 and 12. 18x minus 36. Move that x, move that x. We have 46 equals 17x. X equals 46 17ths. If you put that in your calculator, it will tell you that is the lowest fraction it can go. So, on level, I would take notes of this one. Just copy it down right now, and you'll have it for later. You'll know it's this if you need it. You can always rewind this and go back. So, I think it was Anna that was asking about rational equations. There you go. Let me go back to the question. So, problem from 5-7, like number 9 on test 5. Let me go to test 5. I don't know if that's the on level or the... yes, let's do one of those. Let's do that one, actually. All right, I think this is on level. Maybe honors had this on their test as well. But we're finding all zeros, or a combination of zeros. This is also their short answer. All zeros for negative x to the 5th plus x to the fourth plus x cubed minus x squared minus x plus 7. Okay. So on level, take notes. This is one of your short answers, not this specifically, but pretty close. We need to find all the possible zeros for this. And what I'm going to do, start here. I'm just going to count the times the signs change from negative to positive or positive to negative. So there's 1, changes there. It doesn't change there because it goes from positive to positive. Don't count it. 2, doesn't count, and then 3. Okay, so I have 3 sign changes. What that means is I have either, for my positives, I have either 3 or 1. I always go down by 2. It's like a little staircase. No matter where you started, you're always going to start walking down by 2. You're always going to go down by 2. What I'm going to do next is flip everything with a negative exponent, or with an odd exponent. So, for example, this has an odd exponent, so this becomes plus. Let me use a different color. That becomes plus because this is an odd exponent. Even exponent, so I'll keep it the same. Odd exponent, it will change. Even exponent stays the same. Odd exponent, this. Let's see here. I'm going to recount them. No, 1, 2. So I only have 2 changes. So my negative possibilities are 2 or 0 because it always goes down by 2. So with that, I have positive, negative, I, and my total. So I have 3 or 1 in here. I'll write that just kind of to the side so I remember my positives are going to be 3 or 1. Negatives are going to be 2 or 0. My total is going to be 5 every time because that's my biggest exponent. 5 is my biggest exponent. So I want to do every combination of these two. So I want 3 and 2. I want maybe 3 and 0. I want 1 and 2 and 1 and 0. And every one of these is going to have 5. I didn't go 3 and 1 because those are kind of on the same column. This column can only be a 3 or 1, 2 or 0. So I did every combination. Now to get my imaginary, I add these and figure out what I need left. 3 plus 2, it's already at 5. I don't need any more. 3 plus 0, I need 2 to get 3 and 0 to 5. 1 and 2 is 3. I need 2 to get to 5. And this one I need 4. So that's my answer right there. On level, this is one of your short answers. Know how to do this. Let me go over natural log. Just a little bit. Honors know how to do this. It might show up as a multiple choice. On level, this is your short answer, for sure. I had another request to go over natural logs. Natural logs can be tricky. They're not really any different. So if you get logs, then you're good. E is a big number, 2.71 and a bunch. So if I have a natural log, let's just say of x, that's the same thing as log base e of x. So let's do a little problem. Natural log of x, log base e of x. Let's do a good problem. if you know what I mean. Okay. So we have 4 e to the x minus 11 equals 17. You may be saying to your screen, Mr. Goodrow, we did that problem this week. Yes, I know. What we're doing is trying to find x. What we need to do is get e to the x by itself. So I have stuff like 11 here that can just go away. That 11 can go away. I can get rid of that 4 as well. And these are all our old techniques. E to the x equals 28. If there was other stuff up here, like 2x, e to the 2x, that's okay. We just want to get rid of everything on the sides. We want to get rid of this 4 and this 11. If there's other stuff up here with the x, that's fine. It can stay. From here, let me go back up here. Let me double check it's a good problem for honors as well. Yep, can confirm. Good problem. Good problem. So I want to reorganize this. Remember how we did this? I'll do a very drawn out version. That e is going to come down here to the little number. This is going to come right here to 28. And x is going to go over here. We don't write log with an e, so that'll be ln of 28 equals x. That doesn't seem any more intuitive, but you can actually just put this in your calculator. You can actually just put this in your calculator. Where that is you come here, down this side, you have an ln button. Can we focus? Oh, yeah. Whoops, I forgot to divide it by 28. That's actually 7. That's actually 7, and that's actually 7. You probably can't read that. There you go. That's actually 7. So natural log of 7 is 1.9459. So just commit that number to memory, everybody. Yes, it is 7. Thank you, everybody. Thank you, thank you, thank you. There's your number. All right. How much longer are we going to stay here? We got, how about, I will give you till 8:30. What are some other good problems? Good problems. How about this one? How about this one? Actually, we'll go, this paper will last a long time. All right, here we go. How about this one? 9 over 4ab plus 5a over 6b squared. Great. What we're going to do is combine these. We are going to combine them. We're not like solving for anything. We're just going to put them together. What we need to do is we are going to find a common denominator. So 4 and 6, we have to think about where they meet. 8 doesn't work. I could multiply them together to get 24, but that wouldn't be the lowest common denominator. My lowest common denominator is going to be 12. I need at least an a and at least a b squared. So I need to get these both to this denominator in order to combine them. So how do I get 4 to 12? I need a 3. A's are good, and I need a b. I need one more b to get b to b squared. This one, I need a 2 to get 6 to 12. I need an a. That's actually b squared, so that's already good. Perfect. So let me multiply these together. I get 27b plus 10a squared all over 12ab squared. I don't combine the tops. They don't have the same variables, so I can't put them together. I can sit them next to each other. That's fine. This is fine. But I can't combine that to 37a squared b. So this is our final answer. This is your question. Final answer. Good problem. Different roots. Question 5 on test 6. All right, Brock, let me find that question. I think I know which one you're talking about, but it's a pretty nasty one. I'm sorry I gave you that. That was mean of me. Here, let's go to the standby screen while I look for this question. Question 5. Yeah, that's a good one. Okay, and we're back. So I believe it was the 8th root of 81 over the cube root of, it was the 6th root of 3. All right, so this is gross, and it looks bad, and there's really nothing you can think to do when you look at it. The answer might not be super intuitive, but what we're going to do is take these and write them as exponents. So this becomes 81 to the 1/8. This is probably honors, let's just say that. And then this becomes 3 to the 1/6. Okay, that doesn't appear to be that much easier. I mean, it's all the same information. But one of our little mantras is we want them to be the same bases. If I can get them to be the same base, it'll make my life a little easier. And 81 is a bunch of 3s. How many 3s? Let's find out. 1, that's 9, 27, 81, perfect. So that is 3 to the 4th to the 1/8. Over 3 to the 1/6. So instead of thinking it like this, I'm going to try to get into the same bases. I turned 81 to 3 to the 4th. Well, I can distribute this 4 into this 1/8. And I get 3 to the 4/8 over 3 to the 1/6. I can rewrite 4/8 as 3/6. Why didn't I go to 1/2? Because I'm going to subtract these two exponents. When I have this little format, I can do 3/6 minus 1/6. That's 3 to the 2/6. 2/6 will simplify to 1/3. So that is actually the cube root of 3. That's a pretty ugly problem. But if you remember, take this, put it in exponent form, try to get the same bases, then you can figure it out. Garrett says, is this a good question? Is this a good question? Let me check. I don't know. Yeah, kinda. It's just a good question, not a good question. All right. Let me go back. Let me look at the chat. Finding all the zeros when the degree is 4 when you use synthetic division. Did we do one of those? I don't think we did one of those. If I do, I'll probably just give you a degree of 3. Just like the other kind of problem. Okay, let me think. What short answer have I not done? I think I've done every kind of short answer. I've already lost my papers. I've just been throwing them over here. What other things have we not talked about that you'll go, oh, I can't believe I forgot about that tomorrow? I would say a lot of these problems I would plug into your calculator if you have no idea. Oh, let's look at this one. This one's just tricky. I don't know why the book does this. Oh, let's go. Let me ask that question. How did you get 3/6 from 4/8? The way I got 3/6 from 4/8. Uh-oh, I think I already lost the paper. Yeah, where'd it go? Oh, here it is. Great. How to get 3/6 from 4/8? That's just half. So I kind of did like a stop up here of like half and then went to 1/6. So if you can go straight there, good. If not, do that. This problem is going to get people tomorrow. And I wish it won't. It just comes straight from the book. That's why I didn't change it. I figured if you're studying the book, you'd rather have it exactly like they do it instead of me altering it a little bit. This problem, well, first let me just kind of break it apart. I have square root of -1 and the square root of x plus 3 to the 4th. This is just going to turn into I. Once again, there are some imaginary, like 1 or 2 i's on the whole thing. This one is going to go to square root of x plus 3 squared, which then goes down to x plus 3 squared. And then we'll move that I over here. So this one, you're not like actually foiling it. That's not the point. The point of it is just to get rid of the square root. But this will be one that's kind of like multiple choice. You'll look here and say, oh, it's probably this one. What else? With irrational equations, do you multiply the common denominator across the top or bottom two? You're going to multiply the common denominator across the tops, and it'll cancel on the bottoms. Multiply on the tops, cancel on the bottoms. Question 7 on test 5. Got it. Request for question 7 on test 5. Question 7 on test 5. Find all the zeros of the following polynomial. I will just say focus on what we did earlier using the third degree and then finding one in your calculator and then doing the rest. So I won't ask to the 4th. Use your calculator to do that. I'm going to talk about common logs. That's a good one. Dallas, continuous decay. It's not too different from continuous growth like we did. You just have to remember to add in that -1. If you do that -1, you'll be okay. So I want to do this problem because it's going to get people upset tomorrow. And if I can show you now, then hopefully I can prevent some stress, maybe some gray hairs not growing. How did you find the factors of question 7 on test 5? Kevin, to answer your question, you find the factors by plugging your calculator, going to the graph, and just finding one of them where it crosses. And saying, okay, there's one, I can go factor it out and get the rest. So this one, 8 and 30, there's no easy exponent that takes 8 and 30 and puts them in the same place. So we're going to have to use common logs. So I'm going to just take the log of both sides. Great. Next, I'm going to move this term out front. I can do that with logs. Put a multiplication sign there. All right, so I'm multiplying m plus 1 times log 8 equals log 30. I'll move the log 8 to that side. So I have m plus 1 equals log 30 over log 8. Move the whole 1. So m is going to end up being log 30 over log 8 minus 1. So what I'm going to do, I did all that. I moved everything. I didn't write what this approximately is. I didn't change this. I just kind of kept everything the same. Now I'm going to put this in my calculator, subtract 1 to get an answer. All right, I have log 30 log 8 minus 1, and my answer, I get m equals 0.6356. And the great thing about this is, even if you got this problem and had no idea how to do any of this, if you take this and plug it in for m, it should work. It should tell you, yeah, that gives you 30. So this problem is very doable, even if you don't know how to do. You can take these multiple choice problem answers and plug them in. Don't do that for all the problems. You won't have the time. But for a lot of the problems, you will be able to just plug them in and get an answer. All right. I will do maybe one or two more. And then you all need to go to bed. I need to go to bed. Make sure you get good rest. Don't look for me in the morning. I will be hiding from all of you. But not because I don't love you all. I just don't want to answer your questions anymore. We did that one. We did that one. We did that one. Yeah, this is great. All right, this will be our last one. So last problem. Good question about the why didn't I distribute the m plus 1? If I did, I could have. That's the short answer. Short answer is I could have distributed it. I just didn't have multiple m's to get rid of. So you could distribute it, but if and when you see this problem tomorrow, you don't have to. Can we get a prize if we find you? Absolutely not. You would get the opposite of a prize. I don't know what that is. Wait, what if I have a question about the calculator program? Can I ask you tomorrow morning? I would wait till your exam and then ask your proctor to ask me. Sorry. And you don't need the calculator. The calculator is just a nice little addition. All right, last problem. Last problem. This is the last problem I will work with you in your high school career. Don't cry. 3x squared. All right. This is our problem. We're dividing these two. Whenever you see division, you should just keep change flip and write it as multiplication. That way you can just skip trying to think about it. You can just look at it for what it's going to really be. All right. So we don't want that anymore. We kept changed and flipped. What that means is I keep this term the same. This becomes multiplication. And I flip that. So that's on bottom, that's on top. All right, once I'm here, I actually have some things I can cancel. I have an x plus y that's going to cancel. I have a 3 and a 15, and I'll leave a 5. And the 5 is going to be down here because the 15 is bigger than 3. It's left over down here, not up here. I have x and x squared. That'll leave just an x right here. And that's all I can cancel. So what do I have left? I have an x on top. I have a 5 on the bottom. I have an x minus 1. Nothing I can do with that. There we go. You could distribute it if you want, but I wouldn't. Save some time. All right. Good luck, everybody. Take your time. Charge your calculator. Get some good rest. Tell your parents you love them. I will see you in the morning, but not before the exam starts. I will be hiding. But love you all very much. Good night.